Today I'm going to talk about a really good algorithm for doing quicksort. So what we need for this algorithm is to have our pivot to be at the first position. But if you choose some pivot in the middle of the array or you randomly choose something, then remember to swap it with the first element of the array and then do the algorithm that I'm about to explain. So this algorithm actually works for every sort of array and every sort of pivot that you pick, but with the caveat that you have to move the pivot to be at the zeroth element of the array, then start working on the algorithm. So let's say that now we choose our 6 to be our pivot, and then we run the algorithm through the elements once. Okay, so the algorithm works like this. You're gonna increment your j until you see something that is less than 6, which is our pivot. So 10 is not less than 6, so you increment your I. You increment your j, I'm sorry. You look at here, now j is pointing at this one, but 13 is not less than 6, so you're gonna again increment your j. Now j points at 5, and then 5 is less than 6. So now in this case you have to swap j with I plus 1 element. So now I plus 1 is 10. You're gonna swap this 10 with this 5. Therefore you're gonna have 5 in this position of the array, and you're gonna have 10 in this position of the array. At this step, you're gonna move your j to the next element, and you're gonna move your I to the next element. Now you look at j, it's not less than the pivot, so you're gonna move to the next element of the array, which is 3. Now 3 is less than 6, therefore you're gonna swap 3 with I plus 1. Now you're gonna have, I'm sorry, I is gonna be here. So when you swap 3 and I plus 1, 13 is gonna go here, and then 3 is gonna go here. Then you're gonna increment your I and j. So I now is pointing at 3, and j is pointing at 2. Here you see that your 2 is less than the pivot. So you're gonna again do a swap with swap j with I plus 1. Now 10 and 2 are gonna be swapped. So 2 goes here, then 10 goes here, and then your I is incremented and your j is incremented. Now you look at 11 and 6, and you see you don't have any swapping there. And then when you increment your j, j is gonna fall off the array. So now if we increment our j, j is gonna go here and fall off the array. So therefore the algorithm is done. And the last swap that you do is to swap the pivot with the element that I is pointing at currently. So 6 is gonna go here, and then 2 is gonna go here. Now as you see, the left of 6, we have all of the elements that are less than 6. Okay, so these are less than 6, and then here we have the elements that are bigger than 6. Okay, so yeah. Now the next thing that we do is to go over the left array and to go through the right array and do the same thing. Now let's say that we want to randomly choose a pivot here in the left array. Let's say that our random pivot is this 5 here. Now what we do is to swap 5 with the 0th element of the array. So now you're gonna have 5, 2, 3, and your pivot is here. Then you have your I, you have your j, and then you compare j to the 0th element, to the 0th element, which is our pivot, and you see that j is less than the pivot. What you do is to swap j with I plus 1. So 2 is being swapped by with 2, so 2 is gonna stay at its place. Now what you will do, you're gonna increment I and j. So I goes here, j goes here. You compare 3 to 5, which j is less than the pivot, so you're gonna swap I plus 1 and j, so 3 is being swapped by with 3. Now you're gonna increment j and I, so j falls of the array and I is pointing at here. And again, in the last step, you're gonna swap I with the pivot. So 5 is gonna go here, and 3 is gonna go here. And as you see, everything to the left of 5 is less than 5, and 5 is at the right position. Then what you will do here is to again call quicksort on this one. So 3 is going to be our pivot, I is going to be here, and then j is going to be here. Then j is less than 3, so you're gonna swap j with I plus 1. So 2 is being swapped with itself. Now I and j are both incremented, j falls off the array, and in this step you're gonna swap the pivot with ith element. So you're gonna have 3 and 2. Now you are pretty sure that this one is at the right place. You're pretty sure that this one is at the right place. Now we go to the right portion of the array. Let's say that we choose, let's say, 10 to be our pivot. So 10 is gonna be swapped with the 0th element, as I mentioned before. Now you're gonna have this array here, and you start doing the same thing. So j is compared to the pivot, it's greater than the pivot, so your j is going to be incremented. Now j is less than the pivot, so I plus 1 and j are going to be swapped. So 13 and 8 is going to be swapped. Then j is incremented, I is incremented. Now as you see, you don't have any swaps, so j is going to be incremented and it's going to fall off the array. So in this step, you're swapping ith element and the pivot. So 8, and then here it's going to be 10. Now you're pretty sure that 10 is at the right place because this one is just one element. This one is at the right place. Then you go to this array, and then you're gonna put your 13 to be the pivot with I, and then j is gonna point at here. Then you compare these two. J is less than your pivot, so you're gonna do a swap with j and I plus 1, so 11 is swapped by itself, and your I and j will increment, so j is gonna fall off the array, and then I is gonna be incremented. At this step, you're gonna swap ith element with the pivot, so 11 goes here and 13 goes right here. Because we only have two elements, we are pretty sure that both of them are 100% at the right position. Now if I redraw the array, I'm gonna have 2, 3, 5, 6, 8, 10, 11, 13. Flawless. And that's how you do a really good quicksort.